Breadth first search is another graph traversal method. Now, like depth first search, the basic operation here is to mark vertices as they're visited and to output them or to process them in some order. Now, we saw that depth first search uses either the system stack or it uses an explicit stack to store the vertices. Breadth first search, on the other hand, uses a queue to place the vertices in and to put them in order to be processed. So the first vertex in the queue is then removed, and then all of its neighbors are looked at and they're marked as visited and placed in the queue. In this way, it ensures that none of the vertices or nodes are revisited at any time. And if a node has no accessible nodes, then the next node in the queue will then be removed and processed. And we will walk through an example, a detailed example of using a queue to do breadth first search. We will now use the same graph that we use for the depth first search to walk through a breadth first search example. Unlike depth first search, breadth first search attempts to visit all adjacent nodes before visiting nodes that are a path of length 2 away. Nearly always breadth first search is implemented iteratively. This is not a recursive function. It doesn't lend itself to that. And so we will, and while we use a stack in depth first search, we will use a queue for breadth first search. So we will instantiate a queue. Once again, we will use the same graph and start at the same node. So we will begin at node A. And there's a slight difference here. What happens is before we enqueue items, we will actually mark them as having been visited. This is due to the first in, first out nature of the queue abstract data type. So we instantiate a queue and we mark that first vertex as visited and we enqueue it. And since the queue is not empty, we dequeue it and place it into a variable v, vertex v. And so we've dequeued. And so let's mark A as visited. And now we dequeue A. And then we need to process it immediately. So we dump A out to our output stream. And for each vertex that is attached to the vertex we're looking at, if that vertex has not been visited, we will mark it as visited and we will enqueue it. Now, unlike the depth first search where we put things in reverse, we will just use alphabetical order here. So at this point, we will mark B as visited and we will place it in the queue. And D, place it in the queue. And A is also connected to F, so we'll mark that visited and place it in the queue. And finally, A is connected to G, so we'll mark that visited and we'll place that in the queue. And at this point, we're done. We've processed all of the vertices. No, we haven't processed all the vertices. We have tended to all the vertices that are attached to A. We only processed A in this instance of the loop. Okay, and so we go back to the top of the function and we dequeue B. So I will remove B and I will update the queue. Okay, so G, F, and D are still in there with D at the front. And now from B, we will look at each edge and look at the other vertex. And if that other vertex has not been visited, we will mark it visited and place it in the queue. So B is connected to F, but F has been visited. It's connected to A, but A has also been visited, but it's also connected to E, and E has not been visited. So we will mark E as visited and we will NQ E. Okay, and then this iteration of the loop is over and we will DQ D and F, G, and E are still here, and we just DQ'd D. Okay, so we're here, and oh, we failed to process B last time. Forgive me, so I failed to mark B as processed. So we now have DQ'd D, and we will process D. We won't miss this one. Process D, and now we will look at all the edges incident to D and see if anything needs to be placed on the queue. D is connected to F, A, and that's it. And both of those have been visited, so we will not add anything else to the queue. The iteration ends, and we will now DQ the F. When we DQ F, we will notice that, so we've DQ'd F, so we need to process F. And we will then take note of everything that F is connected to, and that's B, it's been visited, A, it's been visited, D, it's been visited, but also C. C has not been visited, so we mark it visited and we NQ it. Okay, and this iteration ends and we DQ the G, and now we have E in the front and C in the back. When we DQ G, we have to now process G, and so we will dump that out here. And for each edge that is incident to G, we're going to look and see if there are any unvisited edges, and if there are, we're going to mark them visited and NQ them. Okay, so G is connected to A, it's been visited, and it's also connected to E, that's been visited. So there's nothing else to add to the queue at this point, and so the iteration terminates. We now DQ the E, and we're just left with C. And so we need to process the E. And when we process the E, we take note of the elements that are the nodes that are incident to E, and it's just B and G. Both of those have been visited, so there's nothing else to NQ. And so the iteration terminates. We go back to the top of the loop and we DQ C. So I now have an empty queue, and I need to process C, and then look at all vertices that are incident to C. Well, that's just F and H. F has been visited, but H has not, so we mark H as visited, and we add it to the queue. We NQ it. Okay, and that's the only one. So the for loop ends, and we go back to the top, and we DQ the H. And so we DQ the H, and we have to process the H. And we now look at all the edges incident to H. It's just C. C has already been visited, so there's nothing else to NQ. And our Q is empty, so when we go back to the top of the loop, not empty is false, and the algorithm terminates at this point, and the process order for a breadth first search is shown here. From A, we visited B, F, D, and G, all of which are length 1 away, before we visited E, which is length 2 away, either this way or this way, or C, which is length 2 away, again, either through this node, that is the node that gives us the least amount, and then finally a node that is path length 3 away. Okay, and that is breadth first search.